Welcome back to Saxon Math. This is lesson 39, multiplying decimal numbers. It's a new concept. Doris hung a stained glass picture in front of her window to let the light shine through the design. The picture frame is 75 hundredths meters long and 5/10 meters wide. How much of the area of the window is covered by the stained glass picture? So to find the area of a rectangle that is 75/10 meters long and 5/10 meters wide, we multiply 75 hundredths meters by 5/10 meters, like this. One way to multiply these numbers is to write each decimal number as a proper fraction and then multiply the fractions. So it might look like this. 75 hundredths is a fraction, 5/10 is a fraction, and you end up with 375 thousandths. 3 zeros, 3 zeros. 75 times 5 is 375. You could do it that way, or you could write them as decimal numbers and find the answer just by multiplying. You could have 375 thousandths as 3 decimal places, and that 3 is the total number of decimal places in the factors. Like 75 hundredths has 2 decimal places, 1, 2, and 5/10 has 1 decimal place. When you multiply those numbers, the product has the same number of decimal places as there are in all of the factors combined. So the two factors, 75 hundredths and 5/10, those are the two factors combining all the decimal places, 1, 2, 3. This fact allows us to multiply decimal numbers as if they were just simply whole numbers. And then after multiplying, we would count the total number of decimal places in the factors. Then we place a decimal point in the product to give it the same number of decimal places as there are in the factors, like this. So if you have 75 hundredths times 5/10, it's just 75 times 5 is all you would do. 5 times 5 is 25, you would carry the 2. 5 times 7 is 35 plus 2 is 37. And then you count. There's 1, 2, 3. So then you have to go 1, 2, 3 down here, put the decimal 3 places to the left and throw a 0 in front of it. This 375 thousandths is the same as 375 thousandths. So you could look at it like a fraction, like it was here. 75 hundredths times 5/10 is 375 thousandths. Or you could look at it like a decimal, 375 thousandths. That's the same amount. So why can we count the decimal places and to multiply 75 hundredths and 5/10? Because if you look at it, anything times 100 as the decimal or as the denominator, and anything over 10 will result in n times n in the numerator, and in the denominator you'll be in the thousandths place. So if you were to look at this is like 75 hundredths is the same as 75 over n, really. Or sorry, n being 75. And then if you multiplied the 5/10, so 5/10 is simply looking like this, 5/10, you see that it's going to end up being in the thousandths place for the denominator, because 100 times 10 is 1,000. And then 75 times 5 ends up being 375. Let's try another example here. Example 1, multiply 25 hundredths times 7/10. So this is what I would do. You could do two things actually. If you want to do it like this, 25 hundredths, you have to know how to say this fraction properly, times 7/10. You have to know how to say it to know what it looks like as a fraction. In this case, I know that the denominator is going to be 1,000 because there's 1, 2, 3 zeros in it. And 25 times 8, I know what 25 times 8 is. I know that it's, in that case, it would be 200, but it's 25 less than that, so it'd be 175. 25 less than 200 makes it 175 thousandths. I know what this looks like as a decimal because I know what 175 thousandths is. It's this as a decimal. Now, if I was going to write this same problem out in decimal format, that would look like this. You'd have 25 hundredths times 7 tenths, and all you have to do is consider it like this. It's 25 times 7, and that's the same. And then you would consider the decimal places after you get your answer. So you just kind of ignore it. It's 25 times 7, but you can't forget that you have to have those in there to count your decimal places in the end. So to begin with, just pretend like it's 25 times 7. That's 35. Carry the 3. This would be 14 plus 3. 14 plus 3 makes 17. And now I have to count my decimal places. There's 1, 2 here, and 3 here. That's 3 total places. That's what they're putting here. And then they move the decimal from this position once, twice, 3 times. It goes right there. It'd be the same as 175 thousandths. Let's look at another example here. Simplify 2 5/10 squared. Now remember, this means 2 5/10 times 2 5/10. That's what the exponent of 2 means. So if I'm going to do that just as it's written, 2 5/10 times 2 5/10, that's just the same as multiplying 25 times 25. In adding and subtracting decimals, the decimals line straight up. So don't get confused with multiplying and dividing decimals. It doesn't work that way. So I have 25 here, carry the 2. This would be 10 plus 2 is 12. This would be 10, carry the 1. 2 times 2 is 4 plus 1 makes 5. I add these together. I end up with 5, 2. So this would end up being 625. So because that is 625, and then I need to move my decimal 1 place, 2 places to the left. So this would end up being 6 25 hundredths. If I looked at it like a fraction, if it was in fraction form, it actually gets a little bit tricky in this, because then I'd have to change that to 2.5 times 2.5. And this gets a little trickier than actually multiplying the decimals, because then I need to make improper fractions out of this. This would be 5 halves times 5 halves. This would be 25 fourths, and then I'd have to do 25 divided by 4, and I'd end up with 6, and I'd get to 24, and then I'd subtract that. I'd have 1 remainder over the denominator of 4. It'd be 6 1/4 as a fraction. The decimal version of this is actually easier, but that's what, you get 6 25 hundredths is the equivalent to 6 1/4. So why is 6 25 hundredths a reasonable answer? It's because 2.5 is between 2 and 3, and if we were to square 2, that's the same as 4. If we were to square 3, that equals 9. So it has to be somewhere between 4 and 9 as an answer. And our answer ended up being 6 25 hundredths. So that's a reasonable answer. Example 3. A mile is about 1 6/10 kilometers. Marie Cruz ran a 3-mile cross-country race. About how many kilometers did she run? So in this case, I need to multiply. I'm looking at 1 6/10 times 3. So if I'm going to do that just as it's written, 1 6/10 times 3, and I get 18, carry the 1. 3 times 1 is 3, plus 1 makes 4. And I count the decimal places there's 1. The decimal here doesn't count. You don't count that as 1. there's 1 to the right of this decimal right here. And it doesn't just line up, even though it works out this way. We move from this position 1 to the left. So now I've got the decimal in this position, and this would be the proper way. So that's 4 8/10 kilometers is how far. Okay, so you just multiply it as though you're multiplying whole numbers is what it says. And then we count the decimal places in the factors, and there's only 1 in this case. So we'd place a decimal point in the product just 1 place from the right-hand end. If it happened to be something like this, let's say it was 16 hundredths times 3, you're still going to get the 48, but then in this case there'd be 2 places, and that would look like this, guys and girls. So just keep that in mind. This is the answer for the problem here, but this is just an example if you had another place, if it was in the decimals in a different position. And we could go even a step further. If the decimal was like this, you could go on forever, actually. You could go on. But let's just do something a little more extreme here. And let's say it's the same digits, really, times 3 this time. And this is still 48 because 18, carry the 1, plus 1 makes 4. But now I've got to move 1, 2, 3, 4, 5, 6 places. So I have to go 1, 2, 3, 4, 5, 6 places. So I need another 0 in each of those positions until I'm in the proper location. So you notice you just have to count the decimal places in the factors. This is a factor right here. This is a factor right here. So there's no decimal places in this factor, but this one has 1, 2, 3, 4, 5, 6. Therefore, your product or the answer of the multiplication problem needs to have 1, 2, 3, 4, 5, 6 as well. If this happened to be 1 over here, if the decimal was in this position, then we actually have to add another decimal and we have to move it over. So you can see how you just count the decimals in the factors. So let's try that. Let's do letter A first. 15 times 3/10. So for letter A, 15 times 3/10, and I'm just going to write it out like this. I'd have 5 times 3 is 15, carry the 1. This would end up being 4. There's only 1 decimal place, so it should be 4. And let me rewrite that 4. For some reason, the digital pen, it just despises the 4s. But 4 and 5/10. Go ahead and do letter B. So you should have 1 and 5/10 times 3. So in this case, you'd have 15. Carry that, and you'd end up with 4 again. And in this case, you still end up with 4 and 5/10 for the answer to that one. Okay, let's do letter C. 1 and 5/10 times 3/10. So this one would be 1 and 5/10 times 3/10. And 5 times 3 is 15. Carry the 1. This would be 4. And then you see there's 1 place, 2 places. So the decimal has to actually be in this position. It'd be 45 hundredths for letter C. All right, letter D. 15 hundredths times 3. You notice this would be 15, carry the 1. 3 times 1 is 3, plus 1 makes 4. And I count the 2 decimal places there, and look at that. 2 decimal places, 1, 2. 45 hundredths. All right, do letter E. 1 and 5/10 times 1 and 5/10. Let me do that over here for you guys. 1 and 5/10 times 1 and 5/10. That'd be 25, carry the 2. This would be 5 plus 2 makes 7. This would be 5, which goes right below the 1. 1 times 1 is 1. Add those together, I end up with 5. This would be 12, carry the 1. That would be 225, but then I need to count my decimal places in the factors. There's 1, there's 2. That means I need to start from this position and go 1, 2 to the left. My answer for letter E would be 2 and 25 hundredths. All right, let's do letter F over here. Letter F would be 15 hundredths times 10. And I'm going to do this. I'm going to hang that 0 off the end over there, because I know that I don't need to do multiple things here. I could just have that 0 come down into the answer. And now I just have 15 times 1, which is 15. And then I need to count decimals. There's 1, there's 2, there's none here. So I need to move from this position 2 to the left. And that would be the answer, 1 and 5 tenths or 1 and 50 hundredths. Letter G. Let me put letter G right here for us. We have 25 hundredths times 5 tenths. You'd end up with 5 times 5, which is 25. 10 plus 2 makes 12. And I need to count the decimals. There's 1, 2, 3 here. So I need to start in this position. 1, 2, 3 over. I need to throw a 0 in front of that for letter G. Letter H. It is 25 thousandths times 100. So letter H, you need to actually write out the decimal as you see it, but you kind of ignore it. I'm going to hang those 2 zeros off because those are just going to come down in my answer, straight down in the answer. Now I have 25 times 1. I know what that is. That's 25. Now I count my decimal places. There's 1, there's 2, there's 3. There's none here, so I have to move 3 from the right, and that would put the decimal right in that position. I'm going to rewrite the answer to this as 2 and 5 tenths for letter H instead of 2 and 500 thousandths. I want it to just be 2 and 5 tenths. Letter I. Let's put letter I right here. We have 8 tenths. And what does that mean? It means times 8 tenths. It means multiply it by itself times itself. So 8 tenths times 8 tenths. Well, what's 8 times 8? 8 times 8 is 64. So you just pretend like it's whole numbers. Then you count the decimal places. There's 1, there's 2. Decimal moves over twice in this one, and it'd be 64 hundredths. Now, if you were to write that 8 tenths times 8 tenths as fractions, you'd end up with this, 64 hundredths. And look at that, 64 hundredths is written as a decimal right there. All right, and letter J, this is very similar. You have 1 and 2 tenths times 1 and 2 tenths because your exponent is twice, so you have to take it times itself 2 times. Now, some of you might know from if you're really good at math facts, you might already know what 12 times 12 is. And I do. I know it's 144, so I'm just going to write what 12 times 12 is. It's 144. If you don't know what that is, this is what your work would look like. You would say 2 times 2 is 4, 2 times 1 is 2, then you'd have 1 times 2 is 2, and 1 times 1 is 1, and you'd end up with this, 144. And then you have to count the decimals, 1, 2, those are the decimals in the factors. This is a factor here. This is also a factor right here. So your 2 factors, there's 2 decimals to the right of the decimal, 2 places to the right of each of those decimals. So that means we need to move 2 back to the left on this side. You end up with 1 and 44 hundredths as the final answer on letter J there. And then letter K asks, how are exercises A through D similar? So the first part, just answer the first part and then separate it with, not a J, separate it with a semicolon. So separate your answer with a semicolon and then answer how they're different. How are exercises A through D similar? So look at A through D. This was A, B, C, D here. How are they similar? And then tell me, how are they different? So when you look at A, B, C, D, how are they different? All right, nice job today. We'll end there and see you guys tomorrow.